Today we're going to look at additional methods for solving systems of equations. So in the last section, we looked at how we could solve a system of two equations by graphing. So we put both of those equations on the same axes and saw where they crossed. And we knew that where they crossed, that was a solution that would make both of those equations true. So today we're going to look at a way that we can find a solution or an ordered pair, okay, an x, y, that makes both equations true by a method called substitution. All right, and the substitution method involves solving one of the equations for one of the variables. And then substituting this expression for the variable into the other equation. Okay, so the substitution method involves solving one of the equations for one of the variables and then substituting this expression for the variable into the other equation. All right, so let's take an example of what this is going to look like here. So in your first example there, you'll see we have the two equations, y equals 3x and x plus y equals negative 32. So I want to be able to substitute one of these equations into another equation. Well, as we see here, our first equation, y equals 3x. All right, so involves solving one of the equations for one of the variables. Well, this first equation here is already solved for one of the variables. Solve for one of the variables meaning a variable is by itself on one side of that equation there. Okay, in this case, y. So y equals 3x. So the substitution method says I can take that y equals 3x and substitute that in for y into my second equation. So we're going to take our second equation, x plus y, but we know y equals 3x. So instead of writing y there, I'm going to put 3x and still equals negative 32. All right, now we can solve this equation, x and 3x. Well, those are like terms, so we can add those together. X plus 3x equals 4x, and that's equal to negative 32. All right, from here we have 4 times x equals negative 32. The opposite of multiplication is division, so we'll divide both sides by 4. Okay, the 4's on my left will cancel. Negative 32 divided by a positive 4, not a negative. We'll get rid of that negative sign there. Go. So negative 32 divided by a positive 4. So x equals negative 8. All right, and now once we have found that value, okay, so x equals negative 8, well, an ordered pair, remember an ordered pair is a set of x and y. So there's our x, negative 8, but we still need the y value that goes with it. So to get that y value, we're going to go back to our initial equation, our y equals 3x, but now we're going to substitute that negative 8 in for our x. So y equals 3 times negative 8. Well, 3 times negative 8 is negative 24. So y equals negative 24. So our solution, our ordered pair that makes this true, is negative 8, comma, negative 24. And just as we saw with the graphing problems, we can plug these values in into each of our original equations and it will make those equations true. And if it doesn't, we know that we went wrong somewhere with our original solving there. Okay, this next example is for you to try. So at this point, you should pause the video and work through that problem, and then come back after you have finished. Okay, so solving that problem there, we see we should have gotten the answer 2, 6. So you can check your work against what I have there, and then we will move on to our next section here. All right, so as we kind of talked about at the very beginning there, so to use substitution, to solve a system of equations, one of the equations must be solved for a variable, right? So it must be solved for having only one variable on one side of the equation by itself. And again, each of our first two examples were already like that because we had y equals 3x in both examples there. So those were already solved for one variable. All right, so now we're going to move on to the back. We'll look at ones that do not start that way. Okay, so in this example, we do not have one of our variables already solved for here. So we need to find one of our variables that is going to be the easiest for us to be able to solve for. So what we want to look for when we're trying to solve for one of our variables is a variable that has a coefficient of 1 or doesn't have a number in front of it there. So as you look at our two equations, well, we have 3y and 4x in the first equation. So clearly those don't have coefficients of 1. In our second, we have a negative 2x, and then we have just a y. Well, that y, we know, has a coefficient of 1. So solving for that variable is going to be the easiest one for us to solve for. So what we're going to do is we're going to take negative 2x plus y equals negative 3. And we want to solve for y, meaning we want to get y by itself on one side of the equation. Well, that means I want to get rid of my 2x there, right? Or the negative 2x. That's what we want to go away. Well, negative 2x, the opposite of subtraction is addition. So we're going to add 2x. Whatever I do to one side, I have to do to the other. Negative 2x plus 2x is 0, so that leaves just y on the left. Negative 3 and positive 2x, well, those are not like terms, so I can't put them together. So we're just going to write one side by side. 2x minus 3. All right, now we've solved for one of our variables. Now we can use that in our first equation. We can substitute that for y in our first equation to solve for x. So in our first equation, we had 3 times y. Well, now y is equal to 2x minus 3 plus 4x equals 14. We're going to have to distribute this 3 to both pieces of the equation. 3 times 2x is 6x. 3 times negative 3 is negative 9 plus 4x equals 14. 6x plus 4x is 10x minus 9 equals 14. Okay, we will add 9 to both sides. Right, so we'll get 10x equals 23. All right, so I'm just going to move over here to give me a little more space. 10x equals 23. Well, 10x is 10 times x. So our last step is to divide by 10. All right, so then we get x equals 23 divided by 10, which is 2.3. Okay, now that we have solved that for x, right, we can use that value of x in our equation for y, our y equals 2x minus 3, to find our value of y. So we'll go back to that one. y equals 2 times x. Well, now we know x is 2.3 minus 3. Okay, so y equals 2 times 2.3. Okay, so that is 4.6 minus 3. All right, so y equals, well, 4.6 minus 3 is 1.6. So our final solution, our ordered pair, is 2.3, comma, 1.6. And again, we can plug both of those values into each of our equations. And if those values don't make each of our equations true, then we made a mistake somewhere that we need to go back and look for. All right, so here's another one for you to try, similar to the one we just did. So again, go ahead and pause the video, work through this one on your own, and then come back and we will finish up this lesson. All right, welcome back. So on that one, we did get some decimal or fractional answers there. So just kind of as a note, if we were to plug these values in to our equations, we may not get exact answers there. We should get something awfully close. On the left there, you know, we have 6y plus 5x equals 8. We may not get exactly 8 equals 8 because we did some rounding in our decimals here, but we should get something very close, like a 7.999 or whatnot there. Okay? All right, so our last little bit here. So if you get an identity, right, so you solve one of these equations and you get something like 2 equals 2, right? When you solve a system of equations, then we say the system has infinitely many solutions. All right, and if you get a false statement, like 8 equals 2, then the system has no solutions.